Welcome everybody to this new lecture of our paper number 3, waves, oscillations and acoustics. In today's lecture, we will discuss the graphical representation of displacement, velocity and acceleration, and also the kinetic energy, potential energy and total energy of a simple harmonic oscillator, that is SHO. S stand for simple, H stand for harmonic, O stand for oscillator. Okay, so let's start it. So पिछले लेक्चर में हम बात कर रहे थे phase differences between the displacement, velocity and acceleration, and we talked about that the acceleration of a simple harmonic oscillator is leads by the velocity by an angle of pi/2 radian, or you can say it is 90 degree, and acceleration is also leads the displacement by pi radian or 180 degree, and you can say it that acceleration is and displacement are anti-phase because of this phase difference of 180 degree. So now talking about the graphical representation of displacement, velocity and acceleration. So let us consider a particle of mass m which is constituting or executing SHM, that the solution of differential equation, or you can say it as a particle of mass m which executing SHM can be shown by this type of equation. This is the solution of the differential equation of a particle of mass m which executing SHM. So the displacement is shown. Displacement of that particle is shown by this equation, y is equals to a sine omega t plus phi. Then what is the velocity of that particle? What is the velocity of that particle which executing SHM? So velocity is simply the time derivative of displacement. So what is the time derivative of displacement? We do it before that d by dt of this equation. So d by dt of this equation gives you a omega cos omega t plus phi. And acceleration, what is the acceleration of that particular particle which performing SHM or executing SHM? So again, the time derivative of velocity gives the acceleration of that particle. Okay, so time derivative of this velocity gives you the acceleration, or you can say it as the double derivative of displacement also gives you the acceleration of that particular particle. Okay, so acceleration is d2y by dt square. Again, differentiation of this equation with respect to t gives you minus a omega square sine omega t plus phi, because the d by dt or the time derivative of this function, cos function, is minus sine theta. d by d theta of cos theta gives you minus sine theta. So minus a omega square sine omega t plus phi. Okay. Now this equation gives me the displacement of that particle. This equation gives me the velocity of that particle, and this equation gives me the acceleration of that particle. Okay. Now these are some conditions for y is equals to 0. That is, the displacement of the particle becomes 0. Then what is the velocity of that particle? If y is equals to 0, then put here y is equals to 0. Put here y is equals to 0. So this equation becomes 0. That is, a sine omega t plus phi is equals to 0. A is the peak amplitude of that particle, so this cannot be equal to 0. And so y sine omega t plus phi is equals to 0, and the value of sine function is 0 in its 0 angle. So sine omega t plus phi is equals to 0. That is, sine omega t plus phi is equals to sine 0. Okay, look at here. Look at here. What is the consequence here? Is that if you have this type of equation, and if we put y is equals to 0, if we put y is equals to 0 in this equation, what is the consequence behind it is this, that y is equals to a sine omega t plus phi, and put y is equals to 0. So if we put y is equals to 0, then 0 is equals to a sine omega t plus phi. And because a is the peak amplitude of that particle, so a does not equal to 0. So y sine omega t plus phi becomes 0, and sine omega t plus phi can be written as sine 0. Then that's why omega t plus phi becomes 0. That means this quantity omega t plus phi will become 0 by this consideration. If the displacement of the particle is 0, then this quantity will be 0. Okay. Now using this result, if omega t plus phi is equals to 0, then put here this result, omega t plus phi equal to 0. That means a omega cos 0, and the cos 0 has value plus 1. So the velocity of that particle, when the displacement of the particle is 0, then the velocity of the particle becomes a omega, because cos 0 has value of plus 1. So the velocity of the particle becomes a omega when the displacement of the particle is 0. The velocity of the particle will be v is equals to plus a omega. And because acceleration is the time derivative of the velocity, then time derivative of this constant quantity, because this is the constant quantity, a, the peak amplitude is constant, omega, the angular frequency of the particle or the performing SHM is constant. So a omega, this product will be constant, and the time derivative of any constant, which this is actually velocity. If you take the time derivative of left hand side, then you have to take the time derivative of right hand side, then time derivative of left hand side dv by dt gives you the acceleration of the particle, and time derivative of this constant quantity gives you 0. So actually the acceleration of the particle will be 0. Okay, so when displacement of the particle is 0, the velocity of the particle will be plus a omega according to this equation, and the acceleration of the particle will be 0. No displacement, no acceleration, only velocity. Okay. This is the mathematical aspect, and after that we will discuss about the graphical representation. So the second case, the second situation, when y is equals to plus a, that means the displacement of the particle is equals to the peak amplitude of the particle, or you can say it, this equation, this mathematical expression, as the displacement of the particle is maximum, because the maximum displacement is equal to the amplitude of that particle. Maximum displacement is equal to the amplitude of that particle with performing SHM. Okay, if y is equals to 0, अगर y का वैल्यू 0 हो जाए, this, if this y is plus a, then what is the effect on this equation? So let's see it. If y is equals to 0, sorry, y is equals to a, the equation or the solution of the differential equation, or the equation which represents the a particle which represents the displacement of a particle which executing SHM, is a, y is equals to a sine omega t plus phi. Okay, and now use this situation, that if y is equals to plus a, that is the displacement of the particle is maximum, and the maximum displacement is equals to the amplitude of that particle. So y is equals to a, put here y is equals to a, so a is equals to a sine omega t plus phi. So a is cancelled with a, then sine omega t plus phi is equals to 1. And for which angle? Sine have the value of 1, that is sine omega t plus phi is equals to sine 90. That means omega t plus phi is 90 degree. Omega t plus phi is equals to 90 degree. Then put this result into the equation of velocity and acceleration and see the result. Okay. If y is equals to plus a, then this result will come. This result will come that omega t plus phi is equals to 90 degree. Okay. Then omega t plus phi is equals to 90. Then put this result into the equation of velocity. This equation gives me the velocity of that particle which is performing SHM. That velocity of the particle will become a omega cos omega t plus phi, and in this situation you deduce this result that omega t plus phi is equals to 90 degree. So a omega cos 90, and cos 90 has value 0. So velocity of the particle will become 0. Okay, and put this result that omega t plus phi is equals to 90 degree, this result omega t plus phi equals to 90 degree, into the equation of acceleration. So sine omega t plus phi, because omega t plus phi in this situation when the displacement of the particle is equals to the peak amplitude, then omega t plus phi is equals to 90 degree, then sine 90 has value 1, and the acceleration of the particle will become minus omega square a, or minus a omega square. You can write as you want to write. Okay, so this is the second result. This is the second result. When the displacement of the particle is equal to the peak amplitude of the particle, the velocity becomes 0, and the acceleration will become minus omega square a. Okay. Now coming to the third one, when the displacement is equals to minus a, that is the displacement is equal to the, or you can say it as when the displacement is minimum. When the displacement is minimum, minus a. Okay, the particle is performing SHM. This particle is performing SHM. This, so plus a is here. This is the plus a, and minus a is here. This displacement. So the third situation is that when the displacement of particle is equals to minus a. Okay. Then use this equation. Y is equals to a sine omega t plus phi. So use this equation. So you can say it as y is equals to minus a, and y is also equals to a sine omega t plus phi. This is the equation which represents the displacement of a particle which is performing SHM. Then according to these two equations, we have a sine omega t plus phi is equals to minus a, and this will become cancel. Then sine omega t plus phi is equals to minus 1, and sine omega t plus phi is equals to sine minus pi by 2, or minus 90 degree, or omega t plus phi is equals to minus pi by 2 this time. Okay, so when the displacement of the particle is equals to is the minimum, then we have acquired this result that omega t plus phi is equals to minus pi by 2. Then put this result omega t plus phi is equals to minus pi by 2 in this equation, omega cos omega t plus phi. Okay, because omega t plus phi has value minus pi by 2, so cos pi by 2 either with plus sign or minus sign, because the cos is absorbed with the minus sign, then the velocity becomes a omega cos 90, but the value of cos 90 is 0, so the velocity becomes 0. So velocity becomes 0. And what is the acceleration of that particle at this time when the displacement of the particle is minimum? Then put the value of omega t plus phi, and in this case the value of omega t plus phi is equals to minus pi by 2. So put here in this case, put here minus a omega square sine omega t plus phi, and in place of omega t plus phi you can put minus pi by 2, and because sine is not absorbed the minus sign, so this minus sign and this minus sign gives you this plus sign, and omega square a because sine 90 is 1. Okay, so these are the three mathematical representation or mathematical calculation, mathematical observation. When the displacement of the particle is 0, the velocity of the particle becomes a omega, and the acceleration of the particle will be 0. When the displacement of the particle becomes highest or maximum, the velocity of the particle becomes 0 and the acceleration becomes minus omega square a. And the third result is then when the displacement of the particle is minimum, then the velocity will become 0 and acceleration of the particle will becomes plus omega square a. This is a mathematical observation, and this mathematical observation is plotted graphically, and we have these types of graphs. We have this. This is the axis on which we plotted the amplitude, and this graph, this axis has the time t. Okay, this solid line represents the velocity of the particle. This extra solid line, this represents the acceleration of the particle, and this dotted line, this dotted line, this represents the velocity of that particle. Okay, now let us see these consequences when displacement of particle is 0. When displacement of particle is 0, that is at this point. Displacement of the particle is 0 at this point. Okay, this point. At this point, displacement of the particle is 0, and the first condition, the displacement of the particle is 0. This point, the acceleration is also 0. So look at here, acceleration is also 0. Okay, and velocity is plus a omega. Look at here, look at this graph, this dotted graph. Okay, if you can see that this, now you can, I hope you can clearly see that this, when the displacement is 0, this condition, when the displacement is 0, then acceleration is also 0. Then at this point, displacement graph has value 0 at time t equal to 0, and the acceleration is also 0. This solid line represents the acceleration. This extra solid line represents the acceleration, and this dotted line, this dotted line represents the velocity. Okay, now when displacement is 0 and acceleration is 0 at this point, the velocity of the particle will be plus a omega, and look at here, the graph of the velocity is plus a omega. This value here is, this is actually a omega square. This is actually a, this is a omega, this is a omega, and this is a omega square. Okay, now this condition is satisfied. Now look at second condition. When the displacement is maximum, the acceleration is minus omega square a. Look at here. Here is displacement is maximum. This is the maximum displacement is equals to plus a. This point is plus a. Okay. When the displacement is maximum, the acceleration is minus omega square a. Look at here at this point. At this point, acceleration is, this is minus a omega square, this, at this point, this, and at the same point, at the same time, the velocity becomes 0. Look at here, this, the velocity of the particle will become 0. Okay, now analyze the third condition, y is equals to minus a, when the displacement of the particle is minimum, okay, at this stage, okay. Here is the displacement of the particle is minimum, the acceleration will become plus omega square a. Look at here, this, at this time acceleration is plus omega square a, okay, that is maximum, and velocity will become 0. Look at here, at this time velocity will become 0. Okay, so these mathematical aspects or these mathematical observations exactly match this graphical representation. So this is actually the graphical representation of displacement, velocity and acceleration of a particle which is performing or executing SHM. Okay, so now moving forward, and let us talk about the time period and frequency. Let us talk about the time period and frequency of SHM. So look at here, this time period and frequency of SHM. So you can say that a simple harmonic motion is represented by this type of equation. This is the solution of that differential equation, the differential equation of that particle which is performing SHM or executing SHM. So time period, आवर्तकाल आप इसे कह सकते हैं, या आवर्तकाल ही सबसे अच्छा हिंदी में शब्द रहा होगा, आवर्तकाल. A simple harmonic motion is represented by this type of equation. Okay, हमने बहुत सारे सॉल्यूशन उस डिफरेंशियल इक्वेशन के किए थे, लेकिन बाद में हमने ये कहा था कि जो मोस्ट सुटेबल या मोस्ट यूजेबल जो फॉर्म है हम इसी को यूज करेंगे, तो वही हम यूज कर भी रहे हैं. इस तरह की इक्वेशन हमें किसी भी एसएचएम को परफॉर्म करते हुए पार्टिकल की इक्वेशंस को हम इस इक्वेशन के द्वारा दिखा सकते हैं. ओके, नाउ इन दिस इक्वेशन वी कैन इंक्रीज टाइम t बाई 2 पाई बाई ओमेगा. हम इस टाइम को जो t है इसको 2 पाई बाई ओमेगा से इंक्रीज कर रहे हैं. अब देखते हैं कि डिस्प्लेसमेंट पे क्या इफेक्ट आता है. अब लुक एट दिस डिस्प्लेसमेंट, y इज इक्वल्स टू a sin ओमेगा t प्लस 5. ओके, नाउ if we increase the time period t by 2 pi by omega, then the displacement will become a is equals a into sin omega a sin omega, but time is only increased by this factor, so t 2 pi by omega and plus phi is same. Okay, now a sin omega t, when you multiply this factor omega into the bracket, so omega into t, omega t plus omega into 2 pi by omega, so omega is cancelled here, so 2 pi plus phi, and let us say that sin omega t plus phi is theta, and this is actually sin 2 pi plus theta, which is actually equals to sin theta. So y is equals to a sin omega t plus phi, and look at this displacement equation, y is equals to a sin omega t plus phi, and look at this, a sin omega t plus phi. There is no change. That means displacement of the particle after time t is equals to 2 pi by omega is same. पार्टिकल का जो डिस्प्लेसमेंट है वो इतने समय बाद 2 पाई बाई ओमेगा समय बाद एक ही जैसा है. अब ये जो हमने ग्राफ यहाँ ड्रॉ किया था, ये कोई पार्टिकल है जो एसएचएम परफॉर्म कर रहा है. अब एसएचएम परफॉर्म करते हुए इस पार्टिकल का जो एक ग्राफ हमने ड्रॉ किया था, अब इस ग्राफ में एक समय ऐसा है जब पार्टिकल उसी पोजीशन पे है जो वो 2 पाई बाई ओमेगा समय पहले था. यानी यहाँ अगर आप इस पार्टिकल की पोजीशन कहते हैं और ये इस तरह की इस तरह से SHM को परफॉर्म करता है और वापस इसी एक्सिस पे वापस आ जाता है। तो ये जो समय है यहाँ से यहाँ तक का, इसे हम कहेंगे 2 पाई बाई ओमेगा, एंड दिस विल बी इक्वल्स टू द टाइम पीरियड. This will be equals to the time period of that particle which performing SHM. Okay. So this time t is equals to 2 pi by omega gives you the time period of SHO or harmonic oscillator. Okay. So that is the displacement of the particle after time t is equals to 2 pi by omega is same, and hence the time gives this time gives you the time period of SHO, which is equals to t is equals to 2 pi by omega. The displacement of the particle after this time will become same. So this is equation number 13. And frequency. What is frequency? Frequency is the reciprocal of time period. So reciprocal of this equation is omega over 2 pi. This is the frequency of that SHO. This is equation number 14, say. And here is omega is equals to 2 pi n is the angular velocity of the harmonic oscillator. Okay. So this is all about the time period and the frequency of a particle or harmonic oscillator which performing SHM. Now talking about the next topic, which is about the energy of simple harmonic oscillator. What is the energy of simple harmonic oscillator? Okay, so total energy is equals to, you know that it very well, that the total energy any particle, total energy of any particle will be equals to the kinetic energy and plus potential energy of that particle. Kinetic energy plus potential energy. And what is kinetic energy? What is kinetic energy? So we know that the journal expression for SHO is given by this equation. Y is equals to, this is the displacement of that particle or the displacement shown by the SHO. So y is equals to a sin omega t plus phi, and the velocity at any instant is the time derivative of displacement. So time derivative of displacement gives you a omega cos omega t plus phi, that is d by dt of this equation. D by dt of this equation gives you the velocity of that particle or that harmonic oscillator. So dy by dt is equals to a omega cos omega t plus phi. Okay. Then kinetic energy. What is kinetic energy? And we are all familiar to this form of kinetic energy, 1 by half mv square, or you can see it half mv square. Frequently use this equation. So we have velocity now and the equation of kinetic energy. So put this value of velocity a omega cos omega t plus phi into this equation. We have 1 by 2 m is same, and v, what is the value of v? A omega cos omega t plus phi. So this a omega cos omega t plus phi whole square because of this square. So kinetic energy of the particle which performing SHM is equals to half m a square because of this, omega square because of this square, and cos square omega t plus 5. Say this is equation number 15. Okay. This is the kinetic energy of a particle which performing SHM or a harmonic oscillator which executing SHM. Okay. Now talking about the potential energy. What is the potential energy of a particle or a harmonic oscillator which performing SHM? The potential energy is equal to the amount of work done in overcoming the restoring force from the mean position through a displacement y. This. So acceleration of particle, you know that acceleration is double derivative, time derivative of displacement, that is equals to minus a omega square sin omega t plus phi, and can be written as omega square y. Why it can be written as omega square y? Because y is this. Y is equals to a sin omega t plus phi. Only look at this. Y is equals to a sin omega t plus phi. Only this quantity. So look at here. Look at here. A sin omega t plus phi. Yani this quantity and this gives you y. Okay, and omega square is same, minus is same. This negative sign indicates that acceleration directed towards the mean position. Okay, restoring force को हम ma लिख सकते हैं by the Newton's second law of motion. ma acceleration अभी हमने find out किया है, a is minus a omega square sin omega t plus phi, minus is coming out of the bracket m omega square, and what is this? A sin omega t, again y. So minus m omega square y, and let's rewrite this equation as ky, where k is the force constant or stiffness. Okay, hence the total work done by the force through the displacement y is given by W, and which is equal to this definition is equals to the potential energy, and which is equals to 0 to y ky dy. Okay, so this equation gives me k square y by 2. And what is the value of y? What is the value of y? Because the value of k is minus m omega square, so I can write it as 1 by 2. The value of k is m omega square, so m omega square and y square. And what is the value of y here? What is the value of y? This is the value of y. This is the value of y. Y is equals to a sin omega t plus phi. Okay, okay with this. So we have the potential energy is equals to half m omega square, and put the value of y. Y is equals to a sin omega t plus phi. So a square sin square omega t plus phi. This is equation number 16. Okay. Well, then what is the total energy of the harmonic oscillator or a particle which performing SHM is simply the sum of kinetic energy plus potential energy. Okay. So now kinetic energy is half ma square omega square cos square omega t plus phi by this equation, equation number 15. By this equation, kinetic energy is half ma square omega square cos square omega t plus phi. This is equation number 15. The kinetic energy of harmonic oscillator or kinetic energy of a particle which performing SHM is this half ma square omega square cos square omega t plus phi. And what is potential energy? This is simply given by equation number 16, and it is equals to half ma square omega square sin square omega t plus phi. And this factor, this half m omega square, half ma square omega square, and this half ma square omega square is common from both the terms. So half ma square omega square is common, and look at these quantities: cos square omega t plus phi and sin square omega t plus phi. These are cos square theta plus sin square theta, because this quantity and this quantity is common from both the terms. So this is coming out of the bracket, and into the bracket we are left with cos square omega t plus phi and sin square omega t plus phi. And when the angle is same with the square term of sin and cos, which adding to each other gives you 1. So the total energy of the harmonic oscillator is half ma square omega square, this common term, half ma square omega square. Okay, and you can write this total energy in terms of other quantities that you can define. We were define this angular velocity earlier in this lecture. So omega equals to 2 pi n, to put here. So E total is equals to half ma square, and value of omega is 2 pi n. So square of this quantity is 4 pi square n square. 4 pi square n square, 2 is cancelled with 4, so gives you 2 ma square pi square n square, which is a constant quantity. This is also a constant quantity. Half is constant, m is constant, a is constant, omega is constant. So this is also, so you can say the total energy of the particle which performing SHM is a constant quantity or constant energy, or a particle which performing SHM has a constant value of total energy. Okay, from this result we can write that total energy is proportional to the square of the amplitude of that particle, and total energy is also proportional to the frequency, square of the frequency of the particle which performing SHM, or the square of the frequency of harmonic oscillator. So this is all about the total energy or kinetic energy or potential energy. Okay, and this is all about for this lecture, and meet you into the next one. Thank you for now. Okay.